You're listening to Being Built. I'm the host, Aaron Davis, here with Ayman. It's good to meet you in person, finally. So you were referred to me by a mutual friend who said you would be a great guest on the show. And in the first conversation that we had, I was really impressed with the energy you had about your business and some driving passions that you kind of bring to it. So I've been looking forward to this conversation for some time.
Thank you for having me.
So tell me a little bit about what you do. Materials Resources is the name of your firm?
So the firm is a mix between research and development and manufacturing. We take ideas in a napkin and make a product that can sit in an actual production environment. We have between about 40 scientists and engineer and technician all working together under one roof. We have about 33,000 square feet in Xenia Township, Ohio.
That's a lot of big brains in one space. How do you manage? I was going to say, how do you manage all the egos? But it's probably the exact opposite with well-educated folks, right?
Well, the interesting thing is there is that family feeling among all team members. And whoever knows something is so eager to teach somebody who doesn't know, and who doesn't know is willing to ask, please explain that to me. So it's a kind of a mentorship, apprenticeship / producing things. And we do it for various sectors, not just for one sector. So aerospace, defense, automotive, medical equipment. When you are working on the fact that you can go from a drawing to an actual product in hand in very short time, that means a lot.
I've been holding these bullet points in my head from our phone conversation about these things I want to talk about. Your driving passions are one thing that, like, I don't want to spoil or whatever, but I'm excited to dig into that a little bit. I've been holding back a little bit, just kind of like ready to have that conversation. And then also the technical work that you guys do in metallurgy and such. And I don't know anything about it. So I'm not just pretending to have no idea, being curious about the subject. I'm not just doing this for my audience or your audience. I'm actually really curious to learn a few things.
So in the old time, you can think of metallurgists as the alchemists.
Yeah,
so metallurgist will take some dust, some powder, some raw metal, mix them together, and we can make things can be even worth more than gold. So metallurgy is the science of understanding the metals, how they behave and how they interact with each other, and how you can make metals and how you can make alloys and how you mix one metallic element with another metallic element, make a third one doesn't exist. And you will be surprised with still until today make new metals that didn't exist, new metallic alloys that didn't exist before.
Yeah, it's funny. I've had people ask me, how'd you get into recruiting? Because I do executive search and stuff. And you don't major in that in college, right? But you actually did study metallurgy and materials and such, Ph.D., if I recall, for your profile. What compelled you to get into that space, right? Like what vision or I guess interest or whatever was it that's kind of initiated that?
So interestingly enough, my 7-year-old asked me that 2 days ago.
I told you I was going to ask simple questions, but the depth of the naive, right?
And Steve Jobs calls it the breadcrumbs. When you are in a place and you look back and you feel the breadcrumbs, you feel the more you are following the breadcrumbs is thrown in front of your face, one breadcrumb at a time. It will lead to another one. So when I was 12 years old, I watched a movie, and what attracted me in the movie was the president of the United States was going to visit somewhere in the middle of the desert, has a bunch of scientists walking around with white lab coats. He had a big problem and he just wanted to solve it. And I told myself, I want to be one of those scientists that people will seek for an answer. Yeah. And that took me to the first breadcrumb, which I need to understand science. So I focused on understanding science. Then I found I have eagerness to build things by hand.
Okay.
Then I found myself, I need to learn how to build things. So that took me to mathematics.
Okay.
Then I found after that, I said, no, I wanted to really do things that moves, not stationary. And that took me to start thinking about engineering. And in the engineering, I got fascinated to understand the movements and especially engines and how it works and how you convert energy. Took me to mechanical engineering. And after I graduated in manufacturing and mechanical engineering, I found I start working my master's degree. And during my master's, I struggled to understand a piece of metal. In fact, it was a piece of steel. Every day I tested, it gave me different results. So I ran to my professor and said, what's happening? And he told me, you need to speak with Professor so-and-so. He will explain to you. I sat down with him and he said, this is because of the atomic arrangement of your metal. And this is the art of metallurgy. You want to learn more about the metals, you need to learn more about metallurgy. And I started reading about it and I got really, really excited to learn more about metallurgy. By that time, I finished my master's degree in mechanical engineering manufacturing, and I got a chance to submit my resume to seek research assistantship.
Okay.
And I got the research assistantship in the United States, in Drexel University in Philadelphia, to study metallurgy. Background mechanical engineering, the chance was material science, working in titanium, and since then I got hooked.
One step closer to the lab coat in the desert, right?
Yes, exactly. So that is when I start to walking around, really understanding, looking at microscope, understand how this titanium behave. And that was one of the moments I learned metals are a living thing. They are not. They respond to you. You need to ask the right question. You need to press it the right way. You need to move it the right way. It will respond to you.
Yeah.
And I got my doctorate degree in understanding how that titanium alloy was behaving under certain way of loading them.
Yeah.
And that led me to a visiting scientist job at the Air Force Research Lab, where I got the chance to work with a mentor of mine, Dr. Lee Sinyatin, was an extremely knowledgeable scientist in materials science and titanium in particular. And with him, I start moving from the lab coat to now how I'm going to take these lab coat equations and I put it in an actual aerospace production. And after a few years in the Air Force, I found my passion even went deeper. Now I wanted to understand how I look at metallurgical image, we call it microstructure, how I see how the atoms are arranged, and I can compare one image and another. And that comparison, it cannot just be one is prettier than the other. I need a number.
Yeah.
And I use some of the standards, and those standards give me one number, and that number was never consistent. So the third step, I learned how to use some statistics to understand images. And now images for us is a statistical equation that you're able to understand an image and can add images, subtract images, multiply images. And from there, the door will just become wide open.
Man, what a trip. That was a really good narrative of the breadcrumbs, right? I love the analogy and the details along the way that one hooks you into the next. It sounded to me that there was a big breadcrumb there, though, when you ran into a problem, right? And it's funny how sometimes the obstacle defines your strength. It creates you. If you've got to get over a wall, then you become a good climber. If you got to get through a river, you become a good swimmer, et cetera, et cetera. Right? And that obstacle being, the metals, the inconsistent response to you or whatever, kind of drove you into some expertise there. That's pretty cool, man. So what are you doing now?
Well, now we took this knowledge and we had a project one day with one of our collaborators, and he had a 3D printed titanium. And he wanted to understand why it doesn't behave as it used to.
Okay.
And I looked at that and I said, man, we used to just look at the metal as given to us as we order it. Now we can get the chance to make the part here. What does it take? It takes a printer. So we purchased a printer. We get the chance and we got a 3D printer using a laser beam that can melt titanium. And we start melting titanium and making parts out of titanium, and every part will be different than the other one. It depends on how you melt it. Okay. And then you are in the process of creating the part, but creating the metal when you are working with it.
Wow.
Okay. One printer led to another, and now we have 7 laser powder bed fusion printers, 7 laser printers, and one of them also use electron beam. And that we found ourselves limited to smaller spaces. Like the printer is related to the chamber you work with it. So it's about a foot by a foot. And that led us, okay, what you want to go bigger? We got a robotic arm and we attached a wire to it. And now we are making parts that can be a yard by 3 yards.
Wow.
It's very high resolution, very
In multiple kinds of metal alloys.
you name it. One day we do steel, another day we do aluminum, a third day we do titanium, a fourth day we do nickel-based superalloy.
Wow.
One day we do a project.
In the same machine?
That is the impressive piece about it. If you change the feedstock,
Yeah.
you are, and because you are doing repeated welding, it's called micro welding. You are doing repeated welding in 3 dimensions.
Yeah. Okay.
You change the feedstock, you got a new product.
Yeah. So that kind of takes me to the conversation we had on the phone about kind of your driving passions, and we talked a little bit about, our kind of at a macro level, our economy. We're consumers, not producers, right?
Yes.
In the West in general, in the U.S. in particular, and you spoke about, kind of making us producers again.
Yes.
So tell me about that. Like, how does that drive you, or what kind of goes into that?
One of the breadcrumbs is how I choose the United States to become my new home.
Yeah.
And that breadcrumb, I now looking at it, I found it's because of United States is built on small businesses. It's built on innovators. If you are able to have a small business innovate, become a bigger company or one, and just being your own. So the freedom to pursue happiness, and the freedom to do things by hand and own your destiny was one of the biggest motivations. Then over the years, I found we start losing this. We are going a lot more, if I want something, I go buy it from a supermarket, or I wait for it to be sent for me from China. And now everything just flipped over our head. There is so many crucial things we cannot get it from China. And at that time, it hit me. There is a lot of people who like to do things by hand. How many people do you know, they do stuff in their garages?
It's crazy when I tell somebody that I do my own brakes, or that I installed my own floors or whatever. They're like, wow, you can do that? I'm like, it's on YouTube. It's not that complicated. And you just have to want to do it, right?
And you will see a lot of people, they like to do things like that.
Yeah.
You'll see a lot of people, they convert their garage to smaller shops.
Yeah.
So you already have the talent. You already have the eagerness to work. But what you don't have is you don't have the equipment and the methodology to help those. So since Ford pioneered the assembly line, where you need long factories to make cars, and the same thing you applied even for utensils. You have to have long factory, multiple complicated machine. And that was great at that time. But now we found if we are able to create a small factory, think you can have a factory in a shipping container. Even think that you have a factory can fit in your 2-car garage. And that became the center thought of what we work on. What if I can work on any equipment I develop that it will work in 110 or 220 voltage? If you need
regular household.
If you are cornered, we try to get a three phase and increase that. Is not a big deal.
Right.
But if you have equipment that people can use it in their garage, then you have a manufacturer. But we cannot go there yet. Let's go to the intermediate one.
Okay.
You have a lot of people who wanted to manufacture things, and they seek manufacturing places where it's like a happy place. But those happy places wouldn't allow you to have a knickknacks or have something to put at home.
Sure.
But if we allow them to work in a more cohesive environment, that what you produce, you are part of a bigger assembly line.
Okay.
And with that in mind, that led us, we need to understand the metals, the materials. So we need to look at it. So we made one of our microscopes that you are able to plug it in 110 electricity, and you are able to look at the atomic arrangement of titanium. It's called tipolar.
Okay.
For titanium polarized light microscopy. We have your site. Go www.tipolar.com. It would be a spin-off for us.
Okay.
And the pictures come out of this is beautiful. You can use it even to make wall art out of it.
Really?
And the color picture, it reflects how the atoms are arranged inside the titanium piece.
Interesting.
And at the same time, we got project from the Navy to test the titanium, but you want to test it in a faster rate than the expensive mechanical testing machine.
Okay.
So the team invented a flat bending testing machine that can give me the fatigue behavior of titanium, how long it's going to live.
Yeah, okay.
And it also plug into the 110 outlet.
Household.
So now, if you have somebody with a higher degree in understanding titanium behavior, do you want to start a lab in their garage? You have a microscope, you have a fatigue tester, and you can able to get both of them.
And you can export this capability, right? I mean, you and your team have kind of figured out these are the. Yes. Am I understanding that correctly?
And we figured them out, and we made them in a way that they would be commercialized.
Yeah.
That's why we look at the company that will produce a good idea, then we prepare it for a spin-off to be commercialized. And we like other people to take it and run with it.
Yeah.
The same thing in the shop. We have multiple wire EDM to cut pieces of titanium.
Multiple, say that again.
Wire
Okay.
EDM.
Okay, what's
wire
that?
EDM for electrode discharge machine.
Okay.
It's a wire. You put electricity in it, you move it inside the piece of metal.
Okay.
It melts the metal in front of the wire by making an arc.
Okay.
So you're able to use it as if you are cutting a piece of foam.
Yeah.
You can cut blocks of titanium, steel, copper. Wow. So there are many shops around. They have only one machine, and they are fully booked. Due to our need in the company, have 5 of those machines.
Wow.
Do I need to be a machine shop? Well, we can do a job shop. We can do machining in the company. But our desire is eventually somebody will take those work beside us and will use it for our needs and other people's needs. So, but we figure out a lot about this wire EDM, how to program it, how to maintain it. And we have 5 of them and we use them daily. The same thing with our CNC machinings. We have multiple of computer numerical control machines. We have multiple of CNC machines. Do we want to be machinists and do we want to have a machining shop? We do it because we are able to fill a gap.
Sure. Yeah. But you have resource, so use it, right?
Yeah, we have the resource, we have the brains, we have the talent, we have the people who are eager to work with us.
Yeah.
So we in the company vertically integrated, but we have the desire to educate others, to transfer this technology, to have around us multiple companies. Each one of them will be specialized in something, can help me and help themselves.
Yeah.
So we build this equipment, it can be on a seed for another company. And then if somebody is willing to take the risk, we'll sit down and talk about it as long as we have the ability to access those machines. So we generate the idea, we generate the expertise, and that's the goal, is how to enable distributed manufacturing.
Yeah, I love that idea. I mean, I'm kind of a do-it-yourselfer myself, not a scientist by any means or a manufacturer, but the idea of being able to get your hands around a bigger, broader set of tools and capabilities that you can be it's not Etsy making jewelry or whatever else, and you're not building cars in your garage, right? But those things in between where you're building sophisticated product in a small manufacturing operation. I think your website called it a fast factory, right?
Yes.
And so is that what you were just describing? Okay, cool. I loved that term, right? The fast factory, because it is such a cost prohibitive thing to say, okay, I'm going to build this thing. Well, then you have to figure out how you're going to sell 1 million.
Yes. Before
you build one, right?
Yes.
And there's so many obstacles for a business to be effective when you have to scale from the beginning, right? So particularly in an economy like this, where capital now, money costs you a little bit of money now, right? Yeah. It's not free anymore.
Well, it's an interesting time because now the time is even screaming for more manufacturers.
Yeah.
You hear everywhere about the supply chain challenge. The COVID time put huge spotlight in the weakness of our supply chain.
Right. It was really easy to disrupt it.
Absolutely. And now the current war is happening and the other threats we are facing, it shows clearly. Yeah, it's great to depend on other countries to make your stuff. But guess what? If you lose that expertise here when you need it, it's not going to be here. You need years and years to ramp up. The simplest thing, the rebars to build concrete blocks.
Okay.
This is gone long time ago. It is going to take years if we need to redo this again. If we are importing most of the rebar. Now, if the exporting country decided not to send us rebars, guess what? All our bridges is not going to be built.
It's a lot of dependence. That's a lot of sensitive dependency. We're dependent everywhere all the time, but that's some very sensitive dependencies there. So,
And it boils down to a lot of simple things and complicated things. An I-beam, the I-beam that you use it to build these factories. Yeah. It's a steel beam, you get a rolling mill, and it's normally one of those jobs that we lost it long time ago. We're pretty good in doing these things in Pennsylvania and in Ohio. We're pretty good at doing, but they were gone for one reason or another. But now, guess what? If we cannot bring I-beams, you cannot build factories. And we face this problem with the simple timber. When the COVID hit and we cannot get our timber here in time, guess what? Every house will be expensive. Then from there, everything else will be expensive. So when you have local producers that within reach, now you are able to control a lot of your desires for goods to use and also control how fast it can respond.
Sure.
But if you are depending on another country or somebody is far, then that becomes a problem.
And even more critical when it's sensitive things, the healthcare, defense, whatever, high impact, right? Something more than plastic toys.
Yeah.
Right. So that's, we felt that. I mean, we certainly experienced that in these last couple of years.
Yeah.
I have a little bit of perspective on the manufacturing, the exportation of that. For a very, very short time, I ran a crane in a steel mill.
Okay.
until the union and the company were battling, and I decided to step out of that fight and move on. And I'm glad I moved on, because that's an industry that just has not thrived, unfortunately, right? Building and treating steel. And it is an Ohio, Pennsylvania thing a little bit, but largely it's a China thing, right? It's a Russian thing, right? So,
but that is for particular type of steel. That is the steel that everybody start knowing. But there is different types of steel, that the high strength steel, and those high strength steel are very critical to keep, and those we would be superior in this country.
Nice. Yeah, that's good to know.
And like, if you're talking about the steel, you want to make the simplest thing, the knives. If you want to get a steel to make a knife, you can get cheap steel that the knife will rust the second day, or you can get the stainless steel, the knife will dull after it. To get really high quality steel, now you have to go for particular producers of those high quality steel.
Okay.
And those high quality steel, where you get them, Germany, Japan, you can hear about different types of those steels and why they are manufactured there, because of the quality control. Yeah, certain countries will give you cheap steel, will give you cheap steel.
Right.
And that's what it is. But if you need high quality, you will go to Germany and Japanese steel, and some of the one is done in the United States. There is particular steels are done here in Ohio. Yes. Patented by companies was here in Middletown.
Yeah.
Like the steel company, the HK steel, that the steel was made there, and they still making fantastic work here in Ohio. And this is very high quality steel. If you want to use that, you want to use it in an aircraft, or you want to use it in an expensive, just a simple thing as an expensive knife.
Yeah.
You wouldn't go get cheap Chinese steel.
Right. That's the go-to resource. Yeah. Interesting. So speaking of high quality and quality control, let's talk about your team a little bit.
Yeah.
Can I?
Absolutely.
I didn't bring all 40 of them here to interview them, but I am curious how you assembled. It's a challenging thing. I've spent a lot of time trying to appeal to high caliber talent, and it's not easy. So I'm curious how you got this collective of minds together. From what it sounds like, a very smart, diverse, well-educated bunch of people. What's your trick?
I owe it to the team. I'll be totally honest with you.
Okay.
I owe it all to the team. We are able to work together and bring new talent. But when it started, we never started as a company. I want to profit every quarter. I want to profit. No, I'll be honest with you. We are terrible businessmen. we do not know how. Look, we do everything to do with the money, but I wish we can work without the money sitting.
Right.
But what it happened is we started as we need to achieve a particular goal. And that time was a scientific goal. And I got two of my closest friends and worked with me in the company. And we started together slowly, and we did one equipment versus another. Then we start talking to people, and then we found the one that attracted to working with us are the one who share the same purpose. So Simon Sinek, he identified as why, how, and what. Why are you doing something is important than before you start getting what you're doing. And the why we're doing it is the purpose that a lot of team members start attracting to. And the attraction is we are here to solve a problem. And we're gonna solve it in an intellectual way to enable distributed manufacturing.
Yeah. I mean, that's what compelled me to invite you here, right? To have this conversation is the passion that you had about kind of insourcing our capacity to produce, right? Becoming a producer economy. Yes. That's compelling. That's an exciting thing. I think we all feel the pain and the risk of just Amazon, send, you know, we code our website or whatever we do, right? And we're not building anything, right? That's a little scary to see that vulnerability kind of tested and weakened throughout the last couple of years, right? So I love that passion you brought to that. You mentioned a second one. I think it had to do with creating opportunity and kind of building up people. So tell me a little bit about that and kind of what comes to mind when you think about, you know, what you described as that other passion that drives you.
So the thing that, so the team, when we work together, we share that same purpose. But more important is the continually renewed challenges that we receive. So every day, literally every day, we have a new problem that we face, and sometimes nobody else faces it, or somebody else faces it and struggle to solve it. And the team put their head together and try to work through it. And that renewable creativity that I love it. One of my team members, he called it organized chaos. Because you come in the morning, there is a new problem, you want to work on it, and you don't know what it is. But you sit down and you are faced with a new problem, and suddenly you are in the depth of highly intellectual, a lot of hands-on problems to solve. And the team member who doesn't have that in their heart, it always doesn't work out.
Right. They'll stick around, right?
Yeah, you'll find the folks who find that's intriguing. Yeah. That you are starting something and you're going to see it to flourish and you are part of it to grow.
Yeah. It's like some kid show I used to watch as a kid, Perry Mason, some detective show or something, right? It's like you tune into this new episode each day and there's this new mystery to be unraveled, right? And so when you bring energized minds and every day you've got a novel, complex, purposeful problem, that's a great answer to that first question. How do you assemble a great team? That you bring them and feed them problems like that with purpose and with complexity, and they're new. That's, man, I want to go back to school now.
And then the second piece, we always tell them it is a team effort. So the win is for the team and the loss is for the team. Nobody to blame. We do not point fingers. We can sit down and argue with each other. Internally, you said, I can't believe we did that. We rarely point fingers.
Yeah.
Unless somebody is not carrying their weight, and that's very rare to happen. It happens, but very rare to happen. But most of the time, everybody's carrying their weight and somebody's else weight.
Yeah.
Because they do understand all the projects we come, it's a team project. There is no particular person. If the project succeeds, he will be the winner, and everybody will say, yeah, your project win. No, everybody knows.
You don't get your name at the top of the research.
Well,
my name was third.
All of this is the other interesting thing, becomes really irrelevant within our team. The important thing is the problem solved. Did we deliver? And that is the trick.
Yeah, what a great leadership philosophy that is, to acknowledge and give praise and respect, because it's so energizing to be seen and to be respected for the work that you do, for the value that you create, right? And so we all know this as human beings. We want to be seen and respected, right? Yeah. And not everybody gets that because of the nature of their work. You don't necessarily get that opportunity to be noticed and to be respected often enough, right? As often as we kind of feel that need. So when you as a leader are able to do that for folks, just go out of your way to see them, acknowledge them, and respect them. I've found that as a leader to be very energizing of the teams that I've been part of. And I also really enjoy working with other people who are the same way, who are generous about acknowledging one another, right? They're not greedy about me. Those are maybe the most deflating, exhausting people to be with, who are fighting for credit.
Yeah.
Me. That was my idea. That was my design. Right.
When I interview somebody new, I tell them I can't wait until somebody take my office because I miss being in the lab and working.
Do you?
I still go in the lab and I go to my team members and say, teach me how I do this. I know we got the project and you've been working it and I know the details of what you're doing, but I want to do it by hand. Can I get some time to sit down and work on this? And when it becomes very tough, I go to the shop and say, can I have a sample to grind, clean, machine, do anything that just relaxes? Because I think that is a lot of the team members see that's where the fun is.
That's why you started this thing, right? Because you enjoyed building. I mean, that was a couple of the big breadcrumbs for you, right?
Yeah.
So you like building things.
Yeah.
I think that's kind of why I'm a do-it-yourselfer, Ayman, because I like to be able, I put these hardwood floors in, right? Yeah. So I like to be able to do a thing. I just pass emails around for a living, right? And so I like to be able to do a thing where I can say, see that? I did that.
Yeah.
Right? It's fun to kind of build something and see it physically, right? But I get that. I used to work for an entrepreneur who was a developer. It was hard to get him out of the code. We had to give him something to do because he enjoyed it, Yeah. And that was part of the passion that kind of drove him into building a software team or whatever. So sometimes it's the prerogative of that owner to do some of the fun work sometimes, right?
Well, talk about software. Actually, one of the big arm that we use in the company is a cloud computing software.
Is that right? Interesting.
That we developed in the company. One of my colleagues, he took on his shoulders to develop it from scratch. We sat down, we shared ideas what we wanted to be done, and he developed from scratch, and now it's commercial, actually.
Interesting.
So now it's a software, we call it ICAM.
Yeah,
Integrated Computational Advanced Additive Manufacturing.
Okay. And what does it do?
That software is building a virtual manufacturing environment. So we put the material behavior as equations. We put the microstructure as images. And we mimic the process as equations, and we try to run all together to give you both records of what you put in as well as predictive tools or what can it be.
I'd say
change it. So that virtual manufacturing environment, and it's still early on. It's still very, very early on, but so far is a very promising tool.
Interesting. So it will prompt the user for the appropriate inputs necessary for.
So far,
tell me how they would use it.
That's the ultimate goal.
Okay.
But so far, the way you are using it, you input parameters, you input process, you input images, and it helps you to analyze them. And then it has certain codes that will help you to predict the properties of your metal.
I've got a couple of friends you got to meet. Not the gentleman who introduced us. I got a couple of friends you got to meet. Folks who are, it's funny in my business. It's like I talk to people who talk about things I don't understand all the time, right? And so I've just gotten kind of good at saying like, oh, that's interesting. That's kind of like this. You need to talk to this guy, right? So yeah, I've got a couple of friends you got to meet. Probably folks you've seen on the podcast, actually. Yeah. That sounds really cool. And I think again, kind of lends toward that general direction you have to producing autonomy, right? Yeah. Empowering folks.
Distributed manufacturing, how are you going to enable people to communicate?
Yeah.
If they are using different processes in different location, how you gather this information in one place or in a place that everybody can access it if it's needed?
Sure.
How you communicate with them in an efficient way using a pull method, not a push method. Email is a push. When you push everything through an email, your cloud storage is a pull. You have the information there and you pull. So the idea how to give permissions instead of giving the actual data.
Okay.
How we give access rather than just carrying everything and pushing it to the consumer. This way, software consumer.
Yeah. So you get your hands on several different things: manufacturing, metallurgy, kind of small business spin-offs software.
It's all within the team. I think I'm extremely fortunate to be around all these dreams and desires and passions, and I'm just riding at their coats, the tail of their coats, if I can say it. Each one of them is running and carrying so many people behind, and I'm just fortunate that I can have multiple coats I can ride at the same time. That's how I look at every person who joined my company. Is somebody is pulling the company in the general direction we are going towards it, and just my job is to lean on part of their a part of their effort, so I can keep building more and more team.
Well, you got a humble vibe about you, like capable and yet not egotistical, and I think that that provides room for great minds to work. That and figuring out how to pay the bills, right?
That is the most difficult.
It's right. But I've been there.
That's the most difficult. How to pay the bills. Yeah.
Me, it was more in a software context, but I ran a software shop, and it's like I want to create this nice, fun little lab for everybody to kind of do the things they like. But sometimes we got to respond to a customer and work on a project that's not that fun, whatever else, right? But you got to figure out how to get the bills paid.
Yeah.
But otherwise, not adding unnecessary obstructions and pressures and egos and attitudes or whatever. So I'm glad you've been able to assemble some smart people together to do some smart things. So just for the sake of time, kind of, last couple of questions, maybe. What do you, when you think about the next couple of years, what would you like to see happen in your business and your work?
Well, we discovered we run out of space.
Okay.
So I think for my business, we will be seeking a larger space. Because now we started to help to manufacture components, smaller pieces for different customers. Now our goal moving forward is to manufacture subsystems. Subsystem, you manufacture various components and you put them together to a larger OEM that they put it in whatever end asset is being used.
Yeah.
So that will be our goal in the next few years.
Okay.
Now our goal will focus a lot in our manufacturing capability. We'll expand in increasing our manufacturing team from technicians to engineers to scientists to forge ahead with manufacturing. There is multiple needs in the country that we are hoping to be part of the solution to fulfill these needs. As you can look around, there are needs everywhere, and the supply chain now is shaking so hard that unless you are making something and produce something in value, you're not going to last long.
Yeah. So I didn't mean to cut you off. When you think about those next couple of years, expanding over space, and getting into more subsystems and production, what's the biggest obstacle? A building is one. That's the obvious one. What's the biggest obstacle in getting you there in the next?
So there are two big obstacles.
Okay.
Number one is finding capital fast enough to acquire the land, build a building. Number two is finding the talent will fill that. And I am in Greene County, and the folks in Greene County have been amazing and tried to help us through all this process. But as I mentioned a few weeks ago, and they had a small award ceremony in Xenia, and we got the manufacturing award from them.
Wow,
and
nice.
I mentioned to them, when they say it takes a village to raise a child, it takes a whole county to raise a small business.
Yeah.
And Greene County has been amazing help. But I think if we are to have a magic wand to really do things as fast as the market needs it, and as fast as this country needs it, then we will, one, build the building very fast, move in it very fast, two, hire double or triple our size, which means we need to train a lot in the levels from trade school all the way to PhDs. And that by itself is not a simple task. because you have to handle how to raise a lot of money, how to spend it correctly, how to find the right piece of land, how to put the right building on it, and how to find the talent, fulfill it, and more important, make sure your schedule doesn't slip.
I'm glad you're a little bit intimidated, because it means you're chasing something big, right? That's usually a good sign that you're being ambitious, right? That's good.
It is scary, because I believe the country in general in the next couple of years is moving heavily towards manufacturing. There is a lot of opportunities, and at the same time, there is a lot of challenges. And we have to be very aware of the challenges before we bite or leave opportunities. We made the mistake a couple of times, we're a bit bigger than what we can chew. And but we are becoming very careful of doing it. We are moving forward. We would be very aware of what can and cannot be done. And I would be expecting we'll be rejecting few opportunities, because we know very well the opportunities coming a lot more than what many of the current successful businesses can do. And we have to prepare ourselves to learn how to say no.
Yeah.
And that's very difficult if you spend so many years trying to chase.
Yeah. That's what part of that founder syndrome or whatever is breaking that habit of saying yes, whatever, and figuring it out. You have to do that. You bring up, that subject there is near and dear to me, because I've been kind of the number two to a couple of founders, the operating officer, if you will, or by whatever title. So I've done that. I've operated in that function a couple of times, and it is difficult for a founder to go from micro to small and medium for that reason, because you have to start deciding what you're great at and focusing and saying no to a bunch of things. And that gets real tricky for somebody who's been very careful to grab. You go from opportunistic to strategic.
Yes.
It's encouraging to me that you're ahead of that, right? Like, as a leader, you say you're not a good businessman, but it doesn't sound like it to me. You got busted right there. It sounds like you're thinking, man.
I lean a lot in people I trust in my team. I tell everybody, I say, do not hesitate to tell me I'm not saying something. Do not hesitate to tell me I'm taking us in the wrong direction. Tell me that. And I walk around and I ask people sincerely their honest opinion. And I'm very fortunate. I have a few folks who have been transparent and straightforward and telling it as it is, and they keep us all safe. Like the VP for operation, Dan Satko for my company, he has been a very important guidance to say what is can and what cannot be. And a few folks recently joined, and they are all very careful of not to make my ambitions and dreams driving us all to grab a lot of things we cannot do. So I pick up the phone and said, guess what? I have this idea, this opportunity. Can it be done? And sometimes I said, no.
Like, where are you getting the $100 billion out of, right?
No, and the answer is, it's not the money, it is when and who's going to do it. Right. Before you do that, who's going to get this job done? So
it's great that you have the energy to aspire to crazy things, and it's good that you have smart people that you hear, that you listen to tell you the truth. It's a tough balance. It really is. Well, I wish you the best. I'm excited for you, and I kind of want to follow and stay tuned to what you guys build over the next couple of years, and hope you guys all the success. I think it seems to me, I've been really impressed with our first couple of conversations. You got a really good energy, a big mind, and a humble one that I think inspires people to do their best work. So best of luck to you. Thanks for being a guest and having the conversation with me.
Thank you very much.
All right.